Hi students, I hope you all are doing well. In this video, we will explore dice probability by solving all questions related to snakes and ladder game. I hope you all are familiar with this board game. Okay, so let's begin. We always play this game by using a single dice. Okay, so few questions are related to single dice only. Okay, let's say you are playing this game and you are at square 3. Now, if you notice there is a ladder at 5. Everyone wants to climb this ladder in a game. So you see, if you roll 2, you will get this ladder. So now you want to find the probability that when you roll a die, what is the probability that you will roll 2 here? So let's find it. So you want to roll 2 to climb the ladder. So see whether you get lucky this time. So let's say you roll a die. So the possible outcomes are 6 as we know because it's a 6-sided die. So you will either get 1, 2 or 3 or 4 or 5 or 6. So the total outcomes are 6 here. So first step whenever you do a dice question or a probability question is always write your sample space, as I told in my previous video as well. So in the sample space, write your all 6 outcomes separated by commas. What is our question? Question is rolling a 2. You want to see the probability of 2. So in the sample space, how many times 2 is occurring? 2 is happening only once. So the number of favorable outcome is 1 only because 2 is appearing only once. Now we know the probability formula. It is number of favorable outcomes upon total number of outcomes. So favorable outcome is 1 and total outcomes are 6. So probability of rolling a 2 is 1 by 6. Or if you find in percentage, it is going to be 16.6%. So this is about 2. Now let's say you want to roll 6 some other time. So what is the probability of it? So in the sample space, see how many times 6 is appearing. 6 is also appearing once. So probability of 6 is also 1 by 6. Likewise, let's say you want to roll 4. So what is the probability? 4 is also happening once. So it is 1 by 6. So the happening of all these outcomes is same. The happening of or the probability of all these outcomes is 1 by 6. So that is why these outcomes are nothing but equally likely outcomes. Okay, let's continue our snakes and ladder game. Okay, on the board, let's say you are at square number 39. Now, if you see there is a snake at 42 and it is your turn to roll a die. Now, you don't want 3 now because if you get 3 at though you will reach at square 42 and there is a snake at 42. So you want to roll any number other than 3. So let's find its probability. So what is the probability of not rolling 3 in your next roll? Okay, so you will roll a die because it is your turn. So possible outcomes are 6 as we know, right? Total outcomes are 6. Put all those outcomes in the curly bracket. It means write the sample space. Now first find the probability of 3. Okay, now if you see in the sample space 3 is appearing only once. So probability of 3 is 1 by 6 because 3 is happening only once. Now you need to find probability of not 3. So the formula is whenever you have to find the not 3, so you will do 1 minus probability of 3. Now put everything in the formula. It is 1 minus 1 by 6. And when you solve 1 minus 1 by 6, you will get 5 by 6. So probability of not rolling 3 is 5 by 6. Now let's suppose that while playing you are at square 42. Now if you see closely, there is a ladder at 44, a snake at 45 and again a ladder at 47. It means if you roll 2, you will get a ladder. If you roll 3, you will get a snake. And if you roll 5, you will again get a ladder. So it means what is you have to find what is the probability of rolling 2, 3 or 5. And if you see closely, all three are prime numbers. So now let's see what is the chance of rolling a prime number. Now let's find the probability of rolling a prime number. See, steps are same. You roll a die. There are 6 possible outcomes. So total outcomes are 6. Write them in the sample space. Now you have to find the probability of rolling a prime number. So see, there are 3 prime numbers. 2 is a prime number, 3 is a prime number, and 5 is also a prime number. See, what are prime numbers? Prime numbers are those which are divisible by 1 or by itself only. If you see 2, 2 is divisible by 1 and 2 is divisible by itself. So it has two factors. 3 is also divisible by 1 and it is divisible by itself. So it has two factors. Similarly, 5 is also divisible by 1 and it is divisible by itself. Okay, so it has two factors. All of them have only two factors. But 1 is not a prime number because 1 has only one factor, which is 1 only. Okay, now again come to the sample space. There are three outcomes. So what are the favorable outcome? Total number of favorable outcomes are 3. It means when you roll a die, there are three prime numbers, 2, 3, and 5. Now put them in the formula, which is number of favorable outcomes upon total number of outcomes, which is 3 over 6. 3 and 6 both are divisible by 3. So probability is 1 by 2. So when you roll a die, so there are 50% chances that you will roll a prime number. Till now, we have seen all the questions related to single dice. Now we will see few questions when two dice are rolled together. So the first step is how to create a sample space. So let's see how to create a sample space when we roll two dice. See, when we roll single die, see outcomes are 6. There are 6 faces in a die. And when we roll second die, there are 6 possible outcomes. Now see how to create the sample space for these outcomes. Now see, I'm calling this the first thing, this thing as rows and the above one as column. These are columns. So how will you write the sample space? First start from the first row. So you can write 1 comma 1 for this. Now take first row and second column like this. And similarly for the third column, fourth column, the first row and fourth column, first row and fifth column, and 1 comma 6. So these are the outcomes. Now you can consider second row. So you will write second row and first column, second row, second column, second row, third column. Similar way, the last one would be second row, sixth column. Similar way you will do for third row, fourth row, fifth row, and sixth row. And you will cover all these 36 outcomes. So how many total outcomes are there? Since you are rolling two dice, so with the two dice there will be 6 multiplied by 6, 36 outcomes, which is equal to 6 square. And if you roll 3 dice, it will be 6 multiplied by 6 multiplied by 6. It means you will multiply 6 thrice. And if there are 5 dice, so how many outcomes would be there? So you will multiply 6 5 times, or you can write 6 raised to the power 5. So this is how you create sample space. Now let's solve one question with two dice. When two dice are rolled together, what is the probability of getting a sum of 10? So this time we are rolling two dice. So first step is writing a sample space, as I told in the previous slide that how to create a sample space. So how many outcomes are there? There are total 36 outcomes because we are rolling two dice. For the two dice, it is 6 multiplied by 6, or you can say 6 square. Okay, what we are looking for? We are looking for getting a sum of 10. So there are only three as such outcomes when you will get 10 on the dice. When the dice are showing 4 and 6, 5 and 5, or 6 and 4, in these three conditions only the sum will be 10. So how many favorable outcomes are there? There are only three favorable outcomes. Now put them in the probability formula, which is favorable outcomes upon total number of outcomes. It is 3 upon 36. 3 and 36 both are divisible by 3. So the probability of getting a sum of 10 is 1 upon 12. Well, let's see one more question. When two dice are rolled together, what is the probability that you get at least one 4? So again, we are rolling two dice. We know how many outcomes will be there. There will be total 36 outcomes. So first step is always write your sample space. So total outcomes are 36. Now you're looking for at least one 4. It means one or more 4. One dice should show 4 and the other number could be any other number and 4 also. Okay. So if you see the sample space, there are total 11 such outcomes. So number of favorable outcomes are 11. Now put them in the probability formula, which is favorable outcome upon total outcomes. So the probability of getting at least 1 4 is 11 upon 36. Now let's see some interesting question. See how many total dots are there on a standard six-sided die. You must have rolled die many times, but have you ever noticed? See, the answer is 21. If you add up all six numbers, you will get 21. Now see one more interesting question. If you roll two dice together, what is the most likely total you will get? See, the answer is 7. Why 7? Because there are 6 combinations like this. These are the maximum combinations. 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. So the 7 will come up very frequently. See one more question. In a standard die, opposite phases always add up to which number? So if you have noticed while playing, it is always 7. One more question which you try at home. Two fair six-sided dice are rolled. What is the probability that the sum is a prime number greater than 7? Okay, so you try the sum at home. Today we covered only dice probability and I hope all questions were clear to you. See you in my next video. Take care.